Okay, ladies and gentlemen, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good afternoon. First of all, I would like to thank all the participants for joining this technical webinar with the title of Promoting STEM for Sustainable and Clean Energy Future. Our honorable speaker for today is Professor Emeritus Dr. Azah Muhammad. This webinar is organized by IEEE Power and Energy Society PAS Malaysia, IEEE Women in Engineering Malaysia, and co-organized by IEEE PAS Unit 10 Student Branch. I am Afiq Basay from IEEE PAS Unit 10 Student Branch, and I will be the MC for this session. This webinar is broadcasted live on IEEE PAS Malaysia YouTube channel and Facebook platform. If you have any questions regarding the discussed topic, you can type your question in the YouTube and Facebook chat box. I will pose the question to the speaker during question and answer session at the end of the talk. Before we begin to our main agenda for today, I would like to invite Dr. Norfadilah Abdul Aziz, Committee Member of IEEE Power and Energy Society Malaysia, to introduce IEEE and IEEE PAS to all of you. Dr. Fadilah, over to you.
Assalamualaikum. Afiq, can you hear me?
Yes, madam, sure.
All right. So can you see my slides, Afiq?
Yes.
Okay. All right. So Assalamualaikum and good afternoon to everyone. So first of all, thank you, Afiq, for moderating our session today. And also special thank you to our honorable speaker today, Prof. Emeritus Dr. Azah Muhammad, for willing to share her experience and expertise on sustainable and clean energy future. So let me introduce myself. I am Norfadilah Abdul Aziz, one of the executive committee for IEEE PAS Malaysia 2021. So allow me to introduce a little bit introduction on IEEE PAS Malaysia. Okay, so I'm sure majority of you already know what is IEEE. So IEEE, or Institute of Electrical and Electronics Engineers, is an international professional association for electronic and electrical engineering, with its operation office is in New York City, and it has reached globally and have 100,000 of members and cover more than 160 countries. So there are many technical societies under IEEE, and PAS, or Power and Energy Society, is the second largest technical society in the IEEE. And for your information, more than 45% of the IEEE standards are developed by PAS members. So there are lots of benefits you can get when you join IEEE PAS, especially in terms of knowledge and information sharing through online webinars and tutorials, on-site trainings and workshops, and also technical journals, as well as the basic courses for industry novice. So basically, PAS is providing significant resources for training and learning activities for all members. And those resources are entitled for continuing education units, CEUs, as well as professional development hours, PDH. Okay, if you look at the IEEE PAS Resource Center, where you can go to resourcecenter.ieeepas.org, so members can have access up to thousands materials, and it has lots of types of materials where it covers tutorials, videos, technical reports, journals, and as well as conference slides. And the best thing is all is under one place, and it is very informative. So members not only can have access to lots of information, but also networking. As you can see here, PES has global engagement through local chapters, where we have 10 regions altogether here, where as you can see, Malaysia is under Region 10, together with Australia, China, Japan, Singapore, and others. So there are 45 chapters under Region 10. So here are the IEEE PES Malaysia chapters, Malaysia chairs, which started in 1994, where some of them are from industry and some are academician. And as you can see here, our respected speaker today, Prof. Emeritus Dr. Azhar, is one of the IEEE PES Malaysia chapter which was on 2004 and 2005. So thank you, Prof. Azhar, for that. And currently, our IEEE PES Malaysia chairs is Prof. Hazli Mukhlis from University Malaya. Okay, what we did under IEEE PES Malaysia. So we have conducted lectures or talk like what we have today, as well as conferences, and we also give awards for outstanding engineers, where in order for you to get this award, you must be an IEEE PES members. We also have networking with industry and FYP year final FYP projects, FYP awards, and we also conduct senior member drive. Other than that, you can also get funding, especially on humanitarian activities. Okay, so come and join us. Okay, so in order for you to join IEEE PES, you need to join IEEE first. And for student, you can have free PES student membership for 1 year, where if you have already renewed your IEEE membership this year, so you can take advantage to this offer. So I think that's all. So please come aboard and join us. Inshallah, this year we will arrange many activities that all of you can benefit from them. Okay, so thank you for your attention. Back to you, Afiq.
Okay, thank you, Dr. Fadila, for the introduction to IEEE and IEEE PES. We hope that those who have yet to register as IEEE member, please join us as you will get all the benefits mentioned by Dr. Fadila. One of the activity under IEEE PES is the PES Day, which falls in the month of April. Power and Energy Society being one of the societies that govern the engineering aspect of energy production that has resulted in greenhouse gases and global warming, would like to take this opportunity to educate everyone on the possible solution and technological development in effort to slow down the rate of climate change. This year round, the theme of 4th IEEE PES Day is Clean Energy Revolution. Thus, IEEE Power and Energy Society Malaysia, IEEE Women in Engineering Malaysia, and IEEE PES Unit 10 Student Branch come up with the idea to conduct this technical webinar with the title of Promoting STEM for Sustainable and Clean Energy Future. This talk will be given by Prof. Emeritus Dr. Azhar Muhammad. Let us get to know more about our speakers today. Prof. Emeritus Dr. Azhar Muhammad obtained her bachelor's in Electrical and Electronic Engineering in 1978 from King's College, University of London. She then pursued her master's and PhD in Electrical Engineering in 1988 and 1994, respectively, at University of Malaya. Her areas of research specialization are in power quality, power system security, and smart grid. She was an active in IEEE Malaysia and has held position as Vice President as chapter chair of IEEE Power Engineering Society Malaysia chapter in 2004. She also has received several accolades such as IEEE Malaysia Section Best Volunteer Award in 2004, IEEE Past Chapter Individual Malaysia Appreciation Award in 2006, Malaysia Rising Star Award for Women category in 2016, and World Top 2% Scientist by Stanford University in 2020. Ladies and gentlemen, now it is our utmost pleasure to welcome Yambers her, Prof. Emeritus Dr. Azah Muhammad, to present her talk. Please welcome.
Thank you, Mr. Afiq. Assalamualaikum and very good afternoon to everyone. First of all, let me thank IPE PAS Malaysia chapter, IEEE Unit 10 student branch for inviting me to give this talk. So the title of my presentation today is Promoting STEM for Sustainable and Clean Energy Future. In this presentation, first I would like to give a brief presentation on STEM. STEM education, its importance, and how it is implemented at primary, secondary, and at tertiary level, and why we need to promote STEM for sustainable and clean energy, and how to promote STEM, what are the activities that we can do, examples of STEM projects for sustainable and clean energy, and then we can look into how to improve for sustainable and clean energy. Okay. So what is STEM? Everybody knows what STEM stands for: science, technology, engineering, and mathematics. It is a term used to group together these academic disciplines. Okay. It is actually an effort to break down the boundaries between science, technology, engineering, and mathematics. And it is typically used to address in education. So STEM education, it is widely accepted, widely implemented worldwide, I would say in many countries. And in fact, in Malaysia too, STEM education has been implemented in the Malaysian education curriculum starting 2017. So STEM education emphasizes teaching and learning science, technology, engineering, and maths in an integrated manner. It is intended to give students a grounding in STEM starting at an early age, that means in schools. And the pedagogical or the learning approaches used are usually problem-based learning, design-based learning, blended learning, and cooperative learning approaches. I'm sure many of you have heard of these techniques. So why STEM education is important? Well, the world relies heavily on science, technology, engineering, and mathematics for the development. And that's why STEM education is important to prepare and educate students to compete in the changing job market, to cope with the challenges in the fourth industrial revolution, okay, to meet the human capital demand for more skilled workers such as software developer, mechanical engineer, etc. Okay, to maintain competitiveness, to meet economic, scientific, and technology developments, it means we need more STEM workforce. And also to address the National Education Blueprint, which is by introducing STEM in the Malaysian education system, which aims at ensuring that Malaysia has sufficient number of skilled graduates to fill the industries, okay, the needs of industries. So what is the difference between STEM education versus traditional education? In traditional education, we are taught with science and maths as a separate discipline. But in STEM education, the emphasis here is an integrated approach that underscores the interrelation of science, technology, engineering, and maths. And also, STEM education emphasizes student exploration and problem solving as opposed to rote learning in the traditional education. So, what is integrated STEM education? In STEM education, initially the emphasis is on science and mathematics, which are taught in uh, isolated disciplines and not much emphasis given to technology engineering. But integrated STEM education, we have to combine all these four disciplines such that learning, teaching and learning is done in an integrated approach. And when you can solve real life situations and students work collaboratively solving real world problems that we are facing in the 21st century, such as energy crisis, environmental problems, etc. So the outcome of STEM education is that students can develop STEM literacy such as scientific literacy, ability to use science knowledge to understand the natural world, technology literacy, ability to use new technologies, engineering literacy, ability to put scientific and mathematical principles to practical use, and mathematical literacy, ability to analyze and communicate ideas effectively by formulating, solving, and interpreting solutions. Some other outcomes of STEM education is that by applying STEM, students can develop critical thinking and solve problems through real-world applications. And students can also develop financial literacy, digital literacy, teamwork, presentation, creativity, and communication skills. Students can manage technology and promote efficient use of Web2 technologies, find solutions for global issues, and promotes I'm not sure what, high jobs, okay, by having these skills. Okay, at all levels of education, STEM education is introduced at the primary school, secondary, and tertiary level. So at primary school, students are introduced to basic concepts of science, technology, engineering, and maths. In fact, at primary school level 1, students already learning science, right? Besides, of course, mathematics and the languages. So at the primary school, the emphasis is more on stimulating student interest in STEM subjects, and students are encouraged to collaborate and work together. At secondary school, STEM courses become slightly complex as students' intellectual capacity continue to grow. The focus is to develop students' STEM skills through activities involving analyzing local and global issues as well as problem solving. Students will be encouraged to learn more about STEM related careers. So you can see here the picture at school, students at secondary school, students are already exposed to doing some STEM activities, like for example, develop a photovoltaic toy using scrap PV materials. STEM education at tertiary level at colleges and universities, the STEM courses are more complex and challenging, and students need to do problem-based and capstone design projects to solve real-world problems. Students will combine in-class and extra curricular educational activities such as students joining robotic clubs, solar car clubs, and so on. Students are exposed to STEM career challenges to prepare them in industry and community. Here, students normally they do the internships at industry. So from here, they are exposed to STEM career challenges. A bit on the characteristics of undergraduate STEM education. Knowledge of STEM is applied in an integrated manner to solve real-world examples. Teaching and learning approaches are project-based, problem-based. This is very, I think for the engineering students, they are familiar with this. They have to do project-based, capstone project, and problem-based uh, projects. Students learn collaboratively and engage in research, design, evaluate, and innovate. Students need to develop STEM analytical thinking and critical thinking skills. And students here also have to learn independently by finding out more information from the web, for example. Okay, so much about STEM education. Just a little review on STEM education. I'm not really an expert on STEM education, but I have heard about STEM education while I was at the university. Okay, So why we need to promote STEM for sustainable and clean energy? When we talk about sustainable and clean energy, we tend to associate with renewable energy. Okay, and for renewable energy production such as solar, wind, biomass, and hydropower, we need engineers workforce, and engineering is one of the STEM area. So it is important to promote STEM here because RE production is increasing and therefore more jobs can be created by renewable energy, especially for solar photovoltaic. Usage creates most of the jobs per unit of electricity compared to other RE sectors. Jobs are created with the integration. When we talk about sustainable and clean energy, it is not just renewable energy. Jobs can be created with integration of energy efficiency and carbon capture and storage. Okay. So why we need to promote STEM for sustainable and clean energy? If you look at power generation in the global market, for power generation, renewable energy has the contribution of new renewable energy is increasing in many countries. Okay, and for this, more jobs can be created using renewable energy. If you look at SEDA, which is the Sustainable Energy Development Authority of Malaysia, in the policy vision, the vision is to achieve 20% renewable energy capacity mix by 2025 by implementing enhanced net energy metering and solar leasing, implementing large-scale solar program, implementing non-solar RE projects like biomass, hydropower, establishing RE facilitation program in sustainable energy in SEDA, Malaysia, enabling greater access to renewable energy sources. So much emphasis on renewable energy here, and therefore more RE jobs can be created. Okay, and if you were to look at this chart, solar PV, the growth of solar PV is much more, is increasing as compared to other renewable energy sources for Malaysia, such as mini hydro, biogas, biomass, and solid waste. So therefore, more jobs can be created by using solar power energy. Okay, so much about why we need to promote STEM for so sustainable and clean energy. Now, how can we promote STEM for sustainable and clean energy? Here, I think industry can play an important role as by giving career talks, okay, especially for speakers who work in RE related industries. So they can give career talk to universities by relating STEM in their everyday work. And it's also important to create collaborations with industries. Universities need to create collaboration with RE industries to get sponsorships and also industry internship. We can where we can place university students for the internship at these industries. Okay. Uh, Organize field trips. Universities, we can organize field trips to RE related industries such as biomass plants, solar farm, and photovoltaic integrated buildings. Now we have quite a number of solar farms already in Malaysia. Okay. Okay, how we can promote STEM for sustainable and clean energy to students? We encourage students to think through a real sustainable and clean energy problem and come up with a solution. Make STEM project relevant to local needs so that local resources can be made available. For example, in Malaysia, our local needs will be like solar, hydro, and biomass. We can integrate solar, sustainable and clean energy research in undergraduate courses. Or we can, especially for lecturers doing research related to green energy, you can integrate that in your undergraduate courses. In schools, we can provide mentoring to schools, especially for university lecturers. You can provide mentoring to schools by constructing a renewable energy teaching module at the schools, organize training workshop on RE for school students and teachers, apply research grants to promote STEM education through sustainable and clean energy applications. This I have not seen much, but I've seen some research grant to promote STEM education through robotic applications. Okay, develop interactive videos related to sustainable clean energy to assist teaching and learning of STEM, be it in school and also at university level. So these are some of the suggestions that universities can take up. Okay, let's now look at some of examples of STEM projects for sustainable and clean energy. Actually, you can get to see many of these projects that have been carried out worldwide. Okay, so first let us see what are sustainable and clean energy technologies. It is actually not limited to renewable energy alone. Okay, when we talk about energy efficient systems, energy storage, hydrogen fuel cell, carbon capture and storage, electric vehicles, these are all sustainable and clean energy technologies. So examples of renewable energy related STEM projects, these are much simpler projects which can be carried out even at school level, like solar charger for mobiles, solar robot toy, LED lights using solar power, and solar convert for home. Okay, examples of renewable energy related STEM projects again. Some of the projects which I capture from the internet actually. Solar energy tracking using optical sensor, power electronic converters for wind farms, building a pico hydroelectric generator up here. This is a pico hydroelectric generator, and this is a solar powered car. I know Unit 10, they champion the solar powered car. Okay. Solar charge controller using a maximum power point tracking or MPPT and Arduino microcontroller. So in this project, it's slightly complicated, can be introduced at the university level. Okay. Most important here, the controller is to develop that solar charge controller to control the charging of the battery so that the battery do not become overcharged. If it is overcharged, it will damage the battery. I will not go into too much details on the technical of the projects. I'm just showing some projects that have been carried out under STEM. Okay. This is a hybrid solar battery system. The hybrid system generates power using PV panels and batteries. Here, the main components in this system will be the inverter. You convert DC power from battery to AC and also from the PV. And again here, the charge controller plays an important component in the system. Okay, this is an interesting project, which is the IoT-based solar panel dual management system. The project here proposes a solution for theft prevention and maintenance indication of solar panel using Linkit One and sensors. The sensors, dust sensors, current sensors is more for maintenance indication of solar panel, and accelerometer here is a sensor used for theft prevention. The solution in this system here is provide theft prevention for solar panel and also indicate maintenance. So I'm a bit too fast, okay? And for maintenance here indicates the time for maintenance, thereby preventing frequent visits and safe transportation costs, where maintenance is only done if there is heavy dust on the solar panel. Okay, then by doing this, it increases usage and efficiency of solar panel. So this is another project, virtual STEM activity for RE project carried out by students of Now, Goka University of Technology, Japan, especially in this COVID pandemic period, you need to think of ways of how to implement your STEM project. Okay, one way is to implement a virtual STEM activity. So in this project, students design and build a special airplane for harvesting wind energy. Okay, by using technology, the students use computers, special software to solve the problem in a virtual reality environment. So the chart here shows students examine the poster displayed in their virtual classroom, and they have to study the problem. Okay. Here they show students examine items in the building area outside the virtual classroom. Here students relied on science for information about wind energy, and maths and engineering here were used to design the special airplane, which was built with a variety of primitives and virtual materials such as cubes outside the virtual classroom. And here the girls use primitives to build their special plane. And finally, the team proudly displays the completed airplane. I would say that this is like an energy harvesting project where you make use of the wind energy to drive your airplane. Okay, this is one example of a virtual STEM activity project. Next, this can be also implemented renewable hydrogen electrolyzer project. So in this project, renewable energy from wind and photovoltaic power are used. It's integrated, connected to the electrolyzer. Electric current from the renewable energy goes through the electrolyzer, which produces hydrogen to drive the fuel cell car. So here to control the unregulated DC source from the fuel cell, so as to produce a regulated output, you need to design converters. Okay, so this can be considered as an interesting renewable hydrogen project, but I think this project is more suitable for at the university level. Okay, generating electricity from a bicycle while exercising. This can be considered as again as an energy harvesting project. Energy collected from the use of an exercise bike is saved to power cell phones, laptops, etc. Okay, here generator and regulator need to be designed and developed. Electric vehicles have been widely considered as STEM projects. From here, you can see electric vehicles such as battery-powered motorbikes, scooters, and trishaw. Okay, let's so much about STEM projects. I'm sure you can find many more of STEM projects uh, in the internet, and I'm sure also at the university level, some of these STEM projects for sustainable and clean energy have been implemented. Okay, all right. Let's talk about issues and challenges in STEM for sustainable and clean energy. STEM is education, I would say, is considered relatively new in Malaysia because it was only implemented in 2017. So, of course, there will be many issues and challenges that need to be addressed. One, lack of operational funds to carry out RE projects, to purchase devices and equipment. Okay, two, lack of awareness and knowledge on RE technology, especially at schools, I would say. Lack of professional development, including formal teacher training on STEM and RE. Since it is new, we need to train teachers on RE. Lack of students' motivation and involvement in doing STEM-related RE projects, inadequate computer and lab facilities, as well as workspace for doing RE projects. Okay, we need the workspace. This is always an issue, especially at the universities when you do your design projects. Where you have to work with a group of students, you need this workspace. difficulty in getting support from administrators due to lack of understanding on STEM and RE. Okay, so much about the issues. I'm not going to go into much detail. We know what are the issues, I think, most of us. All right, let's have a discussion on how we can improve STEM for sustainable and clean energy. When we talk about STEM, it is not a STEM education, it is not just about curriculum. To implement a successful STEM program, we also need to consider infrastructure like equipment, space, outreach programs, mentoring program, okay, facilities such as what are outreach program will be such as internship, research projects. You also need to look at staffing, facilities, and also advisory boards. This is where the top management plays an important role to give support to the STEM program. So how can we improve STEM for sustainable and clean energy? Enhance faculty professional development. It means give training, enhance on effect, give training to lecturers or school teachers on effective approaches to teaching and training on sustainable and clean energy technologies. Provide faculty with easily accessible resources, learning tools, for example, videos on sustainable and clean energy. If we can purchase these learning tools, we can show to students during classroom. Build partnership, collaborate with industries. This is important, especially with industries, so that we can develop some research and also some STEM activities, and of course to get funding from industries. Okay, and place in students for internship. Establish infrastructure and infrastructure by providing modern instructional approaches and consider reallocation of current spaces. This is more on the infrastructure, which I have mentioned earlier, where we need to provide more workspace to carry out STEM activities. How to improve STEM again for sustainable and clean energy, allocating enough funds to support students in the sustainable and clean energy related capstone design projects. Encourage students to join technical clubs like solar energy club, renewable energy clubs, to help design them in their problem-based and design projects. Because by joining these clubs, students will be exposed to the STEM activities. Students to use enhanced computer-aided tools and virtual online labs to simulate experiments at lower cost and flexible access. This needs independent learning of students. Okay, encourage students to be involved in international collaboration programs on sustainable and clean energy to foster intercultural student. I cannot see what I write. Anyway, to student collaboration, because this has been implemented in many countries worldwide. By having international collaboration programs, students can learn maybe learning materials or learning tools from students overseas, and they can work together to develop a STEM project. Okay, so much about how to improve STEM, especially for sustainable and clean energy. I would like to conclude my presentation by saying a few words here. I would say that STEM education for sustainable clean energy is relevant and important because RE production is increasing and bring a lot of opportunities. That means more jobs can be created from RE production. Okay, and so sustainable and clean energy applications have the potential to enhance, motivate students to pursue STEM education. STEM education is considered relatively new in Malaysia, and therefore research and studies on effectiveness of the curriculum, policies, and initiatives related STEM education at all levels needs to be introduced. I know that some universities, they have developed centers for focusing on STEM education, and some research. I've seen some papers published research carried out by UKM and also UPM. Okay, but then again, we need to develop further on this. Okay, thank you for listening to my presentation. Uh, I shall now return back the floor to the Mr. Afiq. Yeah,
Okay, thank you, Prof. Azza,
and
for
I'm
the
willing.
insight. Sorry, Prof?
Yes, okay. I'm now ready for Q&A,
All right. Hence, ladies and
if there's
gentlemen,
any.
let's proceed with the question and answer session. Those with any questions regarding the sharing by Prof. Azza, please type your question in the chat box on YouTube or Facebook chat box. So our first question is from Professor Madia in Senior Technologist, Dr. Nur Ashida Salim. Okay, so Prof, you want to answer the question?
Oh, yes. Okay, how do you encourage children to venture into STEM related degrees? Oh, salary not competitive? I thought salary is quite competitive. Well, you can encourage, especially you're an engineer yourself, you can encourage them at an stage, even at school level, by introducing, since you're an engineer, well, I think your children will be more exposed to technical terms, but I think you can encourage that. Shouldn't be much problem. Can I have some water? Actually, I'm having a sore throat.
Okay, sure, Prof.
So I hope that answer your question. Okay, as since I'm a parent myself, I think I do encourage my children. Five of I have 9 children. 5 of my sons are in engineering. So that is a STEM related career. Yeah. Um, okay. Any other question?
Okay, next question from Dr. Zuhaila Mat Yassin. Shall I read the question, Prof?
I read the question.
Okay,
Okay,
sure.
during this pandemic, when when everything is moved to virtual platform, will it make students less encouraged join STEM? Well, even during this pandemic, especially for engineering students, I'm not going into schools, schooling students, yeah. For engineering students, whether they like it or not, they still have to do their capstone project, which is a STEM project, really. So they have to be more creative then. They have to think of something that can be done virtually. The students have to explore. This has been done in many other countries as well. So this is where they need to explore to implement that. It shouldn't be less encouraging, especially digital uh, in the current digital era, right? Students use more and more of software. So they should make use of the internet to explore on how to implement this STEM project. Although it's not easy to implement face to face now, yeah. So lecturers also have to think of ways how to, have to think of another way of implementing these capstone projects. During my time, it was not a COVID pandemic time. What are the, from Dr. Minaini, what are the challenges to teach and learn STEM during this pandemic period? What are your suggestions to mitigate this problem? Is it challenging? Well, I'm sure now during this pandemic period, you are teaching uh, your subjects all in online, right? Virtually. So I think, especially for the lecturers, uh, for the lecturers involved in capstone design project, I don't know how you implement in in your university, but in UKM we have a few lecturers. They are involved in the capstone project or design project. So they are the ones who teach the student how to implement such or the STEM projects. Okay, so I don't see much challenges. They have to first give the tutorials, give the explanation on how to implement the projects. But the projects usually come from the students, right? This is where you get the students to be independent. So they have to think of a project, and then only lecturers will see whether it is a suitable STEM project or not. So I don't see much challenges because you can communicate with a student online. But the challenges, of course, maybe you cannot implement the project, a product. That is the big challenge. You cannot come up with the product, but maybe just a design. I hope that answer your question, right, Dr. Miss Zaina? Another question. I am passionate about green energy and sustainability, and I'm now preparing for my final year project. Any suggestion on what should I focus on for my thesis? You don't have a title yet? I would suggest you focus. I have given you some of the suggestions on the project in my presentation. You can look into it. I think you can focus more on solar, on especially which solar is more related to our country. Solar project, there are many solar projects that can be carried out. The IoT based that I have mentioned earlier on the solar panel to prevent theft prevention and for maintenance of the solar panel, that is an interesting project that I can suggest. Yes, next question.
Oh, there is no next question.
So,
So
well,
I
next question.
so I think just now is the last question, Prof.
Oh,
Okay.
we finished early.
Yeah, exactly. So thank you again, Prof. Azza, for answering the question. Okay, so a big announcement before the program ends. We would like to inform that we are going to have an open quiz, which all of participants can join. So the link for the quiz is provided in the chat box. This quiz is based on Prof. Azza talk just now. The quiz will be closed 30 minutes from now, and we will announce the winner on the quiz. Personally, the committee will personally PM the winner. With that, we have come to the end of the program. I hope. Oh, there is another question, Prof. You want to answer?
Okay. Oh, don't you think there's a need of updating curriculum at school levels? Yes, I think there's a need for updating curriculum at school level. As when we talk about curriculum, um, when we talk about curriculum, especially when we want to focus on STEM, uh, at the moment, it's curriculum at school level. Much emphasis is given on science and mathematics, not much on technology and engineering. So, but then, if at secondary school level, there is some changes where, for especially for students in the taking your science and the technology side, they are exposed more to like engineering drawing, you know. Yes, I think there's a need to change curriculum, especially to give examples on technology and as well as engineering career. This is where it comes, I think. Yes, thank you,
Okay,
Dr. Harun Rashid.
so let's see if there is another question. Okay, so there is no question. Okay, so Prof, with that we have come to the end of program. So thank you again for your talk, for your fruitful talk and very insightful. I hope all the participants will continue to
Thank you.
support all of our upcoming programs. Please don't forget to follow IEEE PAS Malaysia and IEEE WIE Malaysia, which is Women in Engineering, Facebook, Instagram, and YouTube channel. And also, do not forget to follow IEEE PAS Unit 10 Student Branch Instagram and Facebook page for any new updates. So I, Afiq Basir from IEEE PAS Unit 10 Student Branch, would like to apologize for any flaws while handling the ceremony. Thank you and have a good day. Thank you, Prof.
Thank you, Mr. Afiq.
Yeah. Hope to see you soon, Doctor.